got simple button. Can you hear me? I can hear me. It'll be fine. I will speak slowly because I'm slightly nervous because this is my first time in the Arctic, so I feel very privileged to be here, and it's already a fascinating meeting. I'm coordinating a very large and growing team of co-authors working on the middle section of the interim report. We're trying to understand thresholds in the Arctic. And I'm going to put all of my conclusions right here on slide 2, so we can be fast. As everybody has already been expressing from our team, we are evolving our approach as we're doing. Especially, we have some really challenging and new interdisciplinary discussions between the whole range of physical and ecological and well, I'm a chemist, chemical sciences on one hand, but also the interfaces with social and economic areas of knowledge and the cultural perspectives as well. And we really want to bring all of these things together. We are trying to push forward our understanding of social ecological systems. And I think, as Annika said, the regional scale is a very new area for us in this field. Often we've been looking at systems that we can kind of, I keep doing it by hand, describe in much more contained terms the processes that matter at our focal scale. One of the challenges we face is that when we're looking at social ecological systems, a huge amount of the literature that thinks about thresholds as thresholds has come from the biophysical sciences, where the phenomena can be understood more clearly and described more clearly. So our approach is already discovering that we need to accommodate many different kinds of phenomena, many different kinds of processes that show threshold behavior, and that means we need to define a threshold in new ways and often quite imaginative ways, I think. And I think one of the other issues that we're trying to focus on is that recognizing that our historic knowledge of change is not always equipping us to be very well. So in the next few slides, I'm just going to go through some different scales of change and sort of explain some of the challenges that we're facing in the process of trying to understand thresholds in social ecological systems. A classic threshold behavior is a shift between two stable states. And when we look at the global level, we have a very good, well-characterized understanding of how the whole planet over the last million years has shifted between ice ages and interglacial stages. We've got a very good understanding of what were the forcing factors that caused those shifts and what are the feedbacks that caused abrupt and rapid changes in the sort of over the last million years. In a sense, we've got a very good we face now is that it's not entirely clear how much that fundamental understanding of how the system works will apply for future change, where there are new forcings, including human intervention in the system, as Johan was saying, and there are, you know, potentially changes to the fundamental feedbacks that work on planet Earth. I liked the fact that Inga-Marie picked up on the North Atlantic Oscillation and the Arctic Oscillation, because again, at the regional scale, we can see that there are often system changes. In this particular case, what matters to us isn't so much the change, the oscillation itself, the change in state, and the pattern of the dominance of one state over another changes. And so one of the questions is a statistical approach to thresholds analysis appropriate for this? Should we be looking at not the change in state itself, but the patterns of changes? And yes, the answer has to be, of course, we should be using these kinds of approaches to understand thresholds. But this presents a brand new set of challenges. it then implies that we can only see thresholds in systems where we've got long time series data, or we happen to be observing the right thing at the right time. I like the fact that Johan also drew upon this particular study of ecosystem change at the much more local level, from one state to another. And this particular study was looking at what happens when a predator species is removed from the ecosystem. Not all system changes are quite so simple and quite so predictable. And even in these examples, there's a very complex trophic web and a very complex set of interactions between the ecosystem dynamics and the state that dominates. So, for example, in the top picture, removing otters from Aleutian Island ecosystems means that sea urchins can increase in population and they graze all the kelp. So you move from a very different kind of kelp-dominated sea kelp forests to a parched desert. These examples show us that, well, one of the things they're missing is what was the original driver of the change that caused the ecosystem shift in the first place. And in many cases, the slow, steady pressure has been human activities influencing the population of these predator species. And so we're interested in problems that are extremely complex and where there can be multiple drivers to the problem. And so the question then is, where do we look for the threshold? Do we look for the threshold in the social system that's causing the problem, the driver? Do we look at the population of otters or of Arctic foxes? Or do we look at the system shift from one kind of vegetation to another? And so those sorts of challenges about how we or multiple drivers presents a new set of challenges for us with our conceptual understanding of what a threshold is. And in that kind of context, I think we're really trying to move towards understanding the multiple causal effects that can cause the system change. We're not just wanting to list a set of system changes from one state to another. We want to be able to really find a way of being more systematic and more formal about the way that we describe the behaviors involved, the mechanisms. And I've had to put the mechanisms in quotation marks because the idea of a social mechanism in particular is a question that's very, very debated at the moment. And we want to well, not the same kind of way, in the same brain as we understand ecosystems. And that leads me to the social thresholds that are of interest. And of course you'll see that this is not an Arctic person. I've picked an example from an ecosystem, or social ecological system that I understand much better. It's got some situations in common. This man is from a community in that for many, well, has a traditional dependence on its ecosystem for its livelihoods that has been subject to increasing encroachment for international development, and where there's a tension between wanting to maintain social and cultural traditions and patterns, but also, and equally, where one of the ways of protecting a local environment might also mean transforming the ways that people interact with that environment. This is from southeastern Amazonia, where currently there's a discussion about mining and about hydroelectric power. And the reason I've included it is partly from a comment by Rasmus Ole Rasmussen, who was saying that we need to understand communities very differently now. Communities, he might well, this is part of a protest against the building of a dam, and the interaction, the worldwide networks of community in responding to environmental pressures can't be kept simply within a location anymore. And we need in our process, in our Arctic resilience work on thresholds, to a new level of linkages around the world. And so that leaves leaves us with a very broad set of questions about what we can say about Arctic social ecological systems where human connections completely transform the dynamics of the natural environment. And in that context, I'm coming back to the rectangle conceptual picture that we've got. We've had a lot of discussions about how we represent the fact that analytically we understand the biophysical and ecological in a fairly compartmentalized way, and we understand the social generally in a fairly compartmentalized way. And in Martin's pictures, we'd kind of represented all the rich and complex interactions as all sorts of things. And I've put a chain again, this chain of links and interdependencies. We might have to change that yet. But I think recognizing that it's that middle area of interlinkages and interdependence that we need to really focus on in this study is our intellectual challenge of the day. We are coming back to that later this afternoon. We're very aware that drivers from different scales put pressure on the system. We know that changes in one component have impacts in another, but equally, these changes feed upon each other. And what we're particularly interested in our understanding of thresholds is trying to understand what kinds of processes might accelerate the change, positive feedbacks that accelerate the transformation in some way, and equally what negative feedbacks exist that help keep the system in its more stable state. And so in our work for this chapter, our basic structuring involves characterizing the drivers, seeking to describe the changes in state and the impacts that are taking place, both in social and in ecological or biophysical terms, and then working out what the mechanisms are that either speed the process up or slow it down. This afternoon, we've got a working session to look at some of the issues about thresholds, and one of the things that I think issue of cross-scale interactions, and again, coming back to Svein's question, we know that many of the forces changing the environment here, the whole human and biophysical environment, are being driven by changes happening elsewhere in the world. And we need to find a way of just simply representing these cross-scale interactions. At this stage, it's very much still at the level of finding ways of conceptualizing change on paper that we can share and that we can debate, rather than necessarily believing that the words we write on paper are the absolute truth about social and environmental change. So one of the things we might do this afternoon is look at, we can see if it works. If it doesn't work, we'll have another workshop later. So to close, I've got a few key messages from the research that we've already compiled. We're doing a literature review of thresholds in biophysical and social systems at the moment. And it's quite clear that many changes are being observed at the moment, in both physical changes and in ecological terms, and to a large extent also in the social world, although, like I said before, it isn't always framed as social thresholds. We can see that there are many shared drivers of change, and we're beginning to understand the dynamics of some of the feedbacks too. But we need to be really honest about the methodological innovation that this chapter needs to do still, particularly in terms of integrating across the social and environmental sciences. The scale problem is already one, but we're really beginning to recognize that there isn't an easy coupling between environmental change and social change. You can't draw a simple line of correspondence. you can't always draw a simple line of correspondence. So sometimes the environment doesn't look like it's changed very much, but a social response can be very great. And equally, we don't need to wait for a threshold in the biophysical system to recognize the need for a large-scale human adaptive effort. This afternoon, where I think we'll be discussing some of these things in more detail. Thank you.